This is our review number 1. Our first part is creating our statement and reasons columns. And then what do we do next? What's our next step?
Wait, what was the first one? Given.
The next step is givens. First step, draw statements and reasons. The second step is list your givens. So my first one is, what is it, Deshaun? EH is perpendicular to GF. And how did you know that?
Given.
Okay, what else do we know? Okay, and how did you know that, G? Okay, so that one's also given. Okay, so right now you know that something's perpendicular and you know that G and F are going to be congruent. I'm going to draw those in. If it is perpendicular, we know that it's forming what? So every time you're told that you have perpendicular lines, the thing that follows, the next step is going to be that the perpendicular lines form right angles. Yep. So we can now say that number 3, angle E, it looks like a weird E. Let's try it again. E, H, F, and angle E, H, G are right angles. So we see that they're right angles. How did we know that? Jack?
Perpendicular lines form right angles.
Perpendicular lines form right angles. Okay, what do we know about right angles? Jack?
That all right angles are congruent.
That all right angles are congruent. So after you know that they're perpendicular, you tell me that you know they're right angles and you know that the right angles are congruent. They always follow that direction. So now we're going to be able to say that angle EHF are congruent to angle EHG. And we know that because of what he said. All right angles are congruent. Okay, I'm going to draw in my other congruent part. Now that I have this, there's something else I know based on the picture. What do I know?
Reflexive.
So Cannon, what's reflexive property? What are we using with it?
What'd you say?
Which part do we apply the reflexive property to?
The proof part.
Wah, wah. Okay. Let's go, Jack.
Line EH.
EH is congruent to
HE.
HE. So remember, if it is a shared side between two triangles, you're always using the reflexive property, saying that that side is congruent to itself because it's in both of them. And I know you know that. You just weren't paying attention there. So when we do this, we can now draw this in. We can list what we have. If you don't have, this is not easy for you to see, I recommend you bringing a different colored pen, and you can write it out like I do. S-A-A. You have 2 angles and a side. So you have 2 options, angle, angle, side, or angle, side, angle. If it's angle, side, angle, it's an included side. Is this the included side where it's congruent between the 2 angles?
Yeah.
So is this side here between these 2 angles?
No, it's not.
No, right? So this has to be? Yep. Angle, angle, side. So your last step is to say what your proof statement was. EFH is congruent to EGH. And you know that by AAS. So, yep, you can go G. What do you have?
HK and LI bisects each other.
Okay, how did you know that, G?
Because it's given.
Okay. So that is the only thing that's currently given.
Okay.
So what does it mean to bisect?
Cut it in half. Through it.
Cut it in half. When you cut it in half, what happens to the 2 parts? They are now split into 2 congruent parts. So we can now say that our 2 parts are going to be congruent. So here we have 2, where we have HJ is congruent to JK. I'm going to do step number 3 at the same time. We also know that LJ is congruent to JI. And how did I know this? Not reflexive. What did we use? We had to have this first to tell us. We have to know what it means to be bisected. So these occurred because of the definition of the segment bisector. So definition of segment bisector. definition of segment bisector. So if you have been bisected by a segment, it cuts the other segment into two congruent parts. So right now we see this happening. I have filled out my picture. Would you like a second?
What is number 2?
So now we see something else based on this picture. What else do we see? There's something in it.
Vertical lines.
Vertical angles.
Angles.
So number 4, we're going to say that angle HJI is congruent to angle KJL. And we know this because they are vertical angles.
Wait.
Yes, sir? HJI
HJI.
and LJK or KJL.
Oh, LKJ.
Okay? So they're vertical angles. You look at what you have. We have enough information to prove stuff. Here, what can we prove? Let's look at what we have. We have a side. We have an angle. We have a side.
It's a sass.
It's a little bit of sass, yep. So we have triangle, HJ.
That's a little bit of sass.
Yep, congruent to KJ. It looks like an I down here, guys. I dropped my pen. It's supposed to be an L. Make sure you recognize that.
I thought it was supposed to be E. Girl.
Yeah, I just dropped my pen.
Hard to see.
So here we have that by side, angle, side. So on question number 3, we're going to do statements and reasons. Brendan, what do you want to tell me?
It's perpendicular to A.
Hold on, let's give him a chance. Statements, reasons. Brendan, what did you have?
No, go ahead. It's fine.
What?
It's all you, dude. I wasn't paying attention to her at all.
Hey, you being extra.
BD is perpendicular to AC.
And how'd you know that?
Because it's given.
Okay, what's my second one?
D is the midpoint of AC.
D is midpoint of AC. How did you know that?
Because it's given.
Okay, so now we're going to build off of our first one, the fact that it's perpendicular. What follows it being perpendicular? Perpendicular lines form?
Right angle.
They form right angles. So our next step is to tell that we have right angles. So angle ADB and angle CDB are right angles. And we know this because of what?
Oh my god.
Sorry.
Bless you.
We know this because perpendicular lines form right angles.
Gee, you're gonna be famous.
For sneezing.
Yeah, your sneeze is going on YouTube.
Okay, so we now know that the angles are right. What do we know about right angles?
They're all congruent.
Yep, they're always congruent. So angle ABD is congruent to angle CDB because all right angles are congruent. So we know all right angles are congruent. I can draw those in. I'm going to move on to my next point. That's spot 5. So we've done everything we can do with the fact that we know we have perpendicular lines. Now we move on to our other one. D is the midpoint of AC. What does it mean to be a midpoint?
It's in the very middle of the line.
It's in the very middle. So what happened to the two sides?
They are congruent and split in half.
Yep. Okay, so that means that AD, I wrote AA, AD is congruent to DC because of definition of midpoint.
So the midpoint, which is.
It's the middlemost point.
So is there going to be a reflexive here instead of BD?
So what happens next, Ryan?
Is that it?
What do we do?
Reflexive.
So BD is congruent to
DB.
DB by
Jack, did she say Jet? No, she did not.
Reflexive.
Exactly.
Okay.
reflexive. Be nice to each other.
I'm saying be nice. I'm the nicest one.
Okay, reflexive property. So we now see we have enough information. Look how exciting this is.
How come we got information now?
Are you done yet?
So when we look at this, we're just about done. We have a side. We have an angle. We have a side.
Sass.
Oh, okay.
So we got a little bit of sass there. So let's do it. We're proving our triangle A.
ABD is congruent to triangle CBD. We know this because of sass.
I don't think
CBD
so. I don't think
congruent by SAS. And we are done with that proof. So our first part is stating what we are given. So I have AD is perpendicular to DC, and that is given. What else do I know?
B is a right angle
A right angle. How did I know that?
because it's given.
Because it's given. And then number 3, Alexis, you ready?
AD is
Parallel.
parallel to BC.
How'd you know it?
Because it's given.
Okay, so we now know that AD is perpendicular to DC. We know that AB is a right angle. And we know that AD is parallel to BC. So let's start with the fact that it's perpendicular. What do we know about perpendicular lines? They form right angles. So we have to say that that's a right angle. Notice the two lines meet at the corner of that rectangle. So we know that angle A, well, actually I don't even have to say that. We can just call it angle D because there's no more angles there. Angle D is a right angle. What do we know about right angles?
They're congruent.
Congruent.
So right angles are congruent. So we know that for number 4's reason, angle D is a right angle because perpendicular lines form right angles.
Ew, who is it?
Wait, so is that, I can't, is that angle?
D. Oh, I made 4 and 4. Let's call that here.
I'm a little, yeah.
Okay, Ryan, let's have you ask your question, hon. So you guys just told me this, but we're going to repeat it again. We now have right angles. What do we know about right angles? So angle B is congruent to angle D because all right angles are congruent. Because all right angles are congruent. So now we know we have congruent right angles. We're going to go on to number 6. What else do we know here?
6,
Reflexive.
can they?
Reflexive. What's reflected? Or what's our reflexive property?
AC. Wait, are you talking about the triangles?
Yep.
Oh, no. Sorry. AC and then CA.
CA, and we call that the reflexive property.
My God, I'm a genius.
He's a genius.
You all are very smart.
And then do we?
So on number 6, so right now all you have, Ryan, is an angle and a side. We're going to need something else. So we're going to have to use the third thing. The fact that they are parallel lines. When we've talked about parallel lines, we've used one thing. Parallel lines cut by a transversal. Inside the lines, opposite sides of the transversal means we're using
Wait, what?
I'm lost.
See, we can use alternate interior angles right here. We also could have used them right here and right here. It would prove the same way. So for step number 7, we're going to say that angle DAC is congruent to triangle, or not triangle, angle BCA.
It's congruent.
And how did you know that? What property?
Alternate interior angle.
Alt and angles postulate. Okay.
I'm not going to get that.
Is that a B?
Where's what?
Is that a B on number 7?
Yep, BACA.
Now we can prove it, right?
Okay, so now we have enough information to
Where's the proof?
prove it. You are correct. So we have an angle. We have an angle and we have a side. Is that an included side?
No.
No.
No. So which one are we using?
As.
As. Okay, so that means we can say our two triangles are congruent. Triangle ADC is congruent to triangle CBA.
What?
So I'm now saying that my two triangles are congruent. But that's not what this is asking for me to prove, is it?
Right.
But to prove any part's congruent, we have to say that our two triangles are congruent. And then our last step is what we learned yesterday. So we can now jump to our proofs. Yep.
How are we supposed to know that?
Okay, so let's focus. We have angle, or segment AD is congruent to BC because of corresponding parts of congruent triangles are congruent. CPCTC. And how you know you're going to use this, anytime it doesn't ask you to prove a triangle, so it's asking you to prove an angle or segments are congruent, you're always going to use that. So when you look at your quiz tomorrow, or not quiz tomorrow, the quiz on Thursday, test on Thursday, if you have this you know you're going to have to use CPCTC. Test Thursday.
She corrected herself.
Okay, so our first one up is to create our table. Statements and reasons. Statements,
Oh my goodness.
reasons. Our first part is to state what we have. BD bisects angle ABC and angle ADC because it's what, G? That's the only thing given. What happens when we bisect something?
It's split in half.
Splits it into two congruent parts, right?
Yep.
So we see that this is bisecting our angles. So now we can write those out. So we have angle ABD being congruent to angle CBD. I'm going to do the next one because it's going to have the same reasoning. And then we have ADB congruent to CDB.
So that's gonna be a last.
And how do we know?
My dear student.
How do we know these two? Definition of? Definition of angle bisector. So just to make sure you plug in what we're doing. So definition of angle bisector. Definition of angle bisector. I'm going to draw in what we just proved. We just stated that this is congruent to this, and this is congruent to this. What else can I do here? Reflexive property. Yep, so we have DB, which is congruent to. Yep. You had it right. I said backwards. So that's reflexive. Now look at what's happened.
Oh my god.
So what do I have here? I have an angle. I have a side. I have an angle. So what can I say?
Angle.
So we can say our triangles are congruent. So you have to say your triangles are congruent, and then you can use your angle, side, angle. So triangle ABD is congruent to CBD. And you guys told me it was by? As a. I've never used that one yet. So angle, side, angle. And then your last step is to look and see, did this ask you to prove the triangles?
No.
No, but you had to do it anyway. So the last step is to state what you have as proof, and what's my reasoning?
CPCTC.
Yep.
CPCTC.
You're smart.
Okay, so by corresponding parts of congruent triangles are congruent. Our first part is to create our table with statements and reasons. Statements, reasons. Okay, so our first thing is to state what we know. We know that C is the midpoint.
Of AE.
Yep, of AE.
And it's given.
And we know it because it's given. Thanks, G. Our next one up is we know that
A is congruent to E.
A is congruent to E. How did you know it?
It's given.
Given. Okay, so we have A and E being congruent. This is only going to follow pretty shortly. What do we know about the midpoint?
Half is congruent.
Congruent parts. So notice how this one says C is the midpoint of AE. It is not the midpoint of both. It is just the midpoint of AE. So we can break this down to AC being congruent to CE. AC is congruent to CE. And we know this because of?
No, I didn't. You just talking to me.
Yep. Thanks, Josiah. Definition of midpoint. So we know because it's the definition of midpoint. So we have this being definition of midpoint. We know this. We know one other thing about this. What do we know?
I don't know.
Vertical angle.
Vertical angle.
Vertical angles. So when you guys see ACB, it's congruent to angle ECB. It's ECD. We know that because of vertical angles. If you guys see a picture that looks like this, an hourglass type of look, bow tie, you're going to be using vertical angles. So if you see it, know that you're going to use it. So that leads me to having this be congruent to here. So what can I say at this point?
5.
As
We could say now that our triangles are congruent, right?
So would it be ACD now, or like?
So
We're doing the proof.
you can do it in the order as long as you're corresponding, Ryan. So I just started with A, C, B
So ACD
is congruent to
DCE.
E, C, D. Yep.
Oh yeah, I see it.
And how did I know that?
Yeah.
Angle, side, angle. And then our last part is the congruent parts. AB is congruent to DE. And we know this based on CB, CTC. Congruent our corresponding parts of congruent triangles are congruent.